Hi, welcome to my channel Mathematics Made Easy by Mary MJ. Today I am discussing class 11 chapter 3 trigonometric functions. We are continuing the chapter. Moving on to trigonometric equations. First we should know what is called trigonometric equation. So equations involving trigonometric functions of a variable are called trigonometric equations. That is, in an equation if sin x, cos x or tan x or any trigonometric functions are there, then we say that such an equation we can say that it is called trigonometric equation. Now here we are finding out how to solve trigonometric equations, and after solving the trigonometric equation, if we are getting the solution if it is coming between 0 and 2 pi, then we call it as principal solutions. Principal solutions. So what are principal solutions? After solving trigonometric equations, if we are getting the solutions in between 0 and 2 pi, then we call it as principal solution. Then all the complete solution, that is called, all the solutions we call it as general solution. So that will be in terms of n, all solutions. So generally we write in terms of n. All solutions we call it as general solution. So what are principal solution? Principal solution means the solution of a trigonometric equation for which it is coming between 0 and 2 pi. 0 less than or equal to x less than 2 pi, we call it as principal solution, and all the solutions of a trigonometric equation we call it as the general solution. Now in order to solve the trigonometric equation, we are having three theorems. So before moving on to that theorems, I'll just show you what are principal solutions. So for that, I'll take one example. Find the principal solution. Find the principal solutions of the equation sin x equal to root 3 by 2. So for which all values, here what you have to find is what are the values of x. So that is called the solution, and we should find out what are the principal solution, that is what all values of x comes between 0 and 2 pi. So sin x equal to root 3 by 2. And for which value of sine we are getting root 3 by 2? That is for 60. We know that sine 60 is equal to root 3 by 2. Or we can write 60 can be written as sine pi by 3 is equal to root 3 by 2. And this pi by 3 is between 0 and 2 pi. So that is one solution. Again we have to find out with any principal solutions, again any other principal solutions are there, that is which is coming between 0 and 2 pi and giving sine value as root 3 by 2. So we'll check, and so we know that sine of pi minus pi by 3, sine of pi minus pi by 3 is the same as sine pi by 3. And what is sine of pi minus pi by 3? It is sine 2 pi by 3. Sine 2 pi by 3 can be written as sine pi minus pi by 3, and sine pi minus theta is the same as sine theta, or sine pi by 3. Sine pi by 3 is again root 3 by 2. So we can see that sine 2 pi by 3 and sine pi by 3 are having these two are having root 3 by 2 as a solution, and this pi by 3 and 2 pi by 3 are both in between 0 and 2 pi. What is this 2 pi by 3? Pi by 3 we know it is 60. 60 into 2, 120. So 120 is between 0 and 2 pi. So we can say that another value which comes in between 0 and 2 pi and having the value as root 3 by 2 is 2 pi by 3. 2 pi by 3 is also coming between 0 and 2 pi. So the principal solutions, what are the principal solutions? So any other values are coming, remaining all it will be either this side outside, both will be outside. It will not come in between 0 and 2 pi. Any other values if you are taking also, it will not be coming between that. So the principal solutions are x equal to pi by 3 and 2 pi by 3. Now next question. Find the principal solutions of the equation tan x equal to minus 1 by root 3. So we should know in which interval, whether it is coming between 0 and 2 pi. Tan x equal to minus 1 by root 3. So we know that tan pi by 6, tan 30 is 1 by root 3. So we should get what is tan, which value of x we are getting it as minus 1 by root 3. For that we have to take tan pi minus theta. What is tan pi minus theta? Tan pi minus theta is minus tan theta. And tan x equal to minus 1 by root 3. And how can I write this tan x equal to minus tan, what is 1 by root 3? Tan pi by 6. So here I am getting minus tan pi by 6. Minus tan pi by 6 is the same as tan pi minus pi by 6, because minus tan theta means it is tan pi minus theta, and that is equal to tan 6 pi minus pi is 5 pi by 6, and that is also this. So x we are getting it as x equal to 5 pi by 6, and what is the value of 5 pi by 6? 5 pi by 6 means 30 into 5, 150, which is coming in the interval 0, 2 pi. So that is one solution. Again we need to find out more. So we know that tan of 2 pi minus pi by 6 is also minus tan pi by 6. So which all values you are getting it as minus tan theta, that you have to list it out first. Tan pi minus theta is minus tan theta, same way tan 2 pi minus theta is also minus tan theta. So these all results you have to study it first. So now tan 2 pi minus pi by 6 is minus tan pi by 6, and minus how much is tan 2 pi minus pi by 6? That is tan 12 pi minus pi is 11 pi by 6, and so this side it is tan x equal to tan 11 pi by 6, or x is equal to 11 pi by 6, which is another solution, and we can check whether it is coming between 0 and 2 pi. Pi by 6 is 30, 30 into 11 is 330, which is an element of 0, 2 pi. It can extend up to 360. So these two are the solutions, principal solutions. So principal solutions are 5 pi by 6 and 11 pi by 6. Again next one if you are taking, it will be moving out, because now itself it is 11 pi by 6. Then so next number it will be more than that. So these two are the solutions. Now in order to find out the general solution, we have to learn three theorems. Theorem 1. For any real numbers x and y, for any real numbers x and y, sin x equal to sin y implies x equal to n pi plus minus 1 raised to n into y, where n is an element of integers. Okay, what is that? if sin x equal to sin y for any real numbers x and y, if sin x equal to sin y, then x can be written as n pi plus minus 1 raised to n into y. Same way, if it is in terms of cos, so for that we will write theorem 2. For any real numbers x and y, for any real numbers x and y, cos x equal to cos y implies x equal to 2n pi plus or minus y, where n element of z. So, if the values both are given in terms of cos, then we can write x equal to 2n pi plus or minus y. If both are in terms of sine, then x equal to n pi plus minus 1 raised to n into y. Now, if both are in terms of tan, for if x and y are not odd multiple of pi by 2, odd multiple of pi by 2, then tan x equal to tan y implies x equal to n pi plus y, where n is an element of z. Here in this case we can see that if it is odd multiples of pi by 2, then tan becomes infinity. That's the reason why it is written that if x and y are not odd multiples of pi by 2, then tan x equal to tan y implies x equal to n pi plus y, where n is an element of z. Now, using this we can find out the general solution. So, what are the theorems which we have learned? If sin x equal to sin y, then x equal to n pi plus minus 1 raised to n into y. Cos x equal to cos y, then x equal to 2n pi plus or minus y. And if tan x equal to tan y, x equal to n pi plus y. Okay. Now, next one question. Find the solution. Find the solution of sin x equal to minus root 3 by 2. Find the solution of sin x equal to minus root 3 by 2. So, sin x equal to minus root 3 by 2. That is equal to minus, for which value of sin we are getting it as root 3 by 2? We are getting it as root 3 by 2 for 60, sin 60, that is sin pi by 3, and minus sin pi by 3. How can we make it as positive? We know the result sin of pi plus theta is equal to minus sin theta, and here we have the result minus sin pi by 3. So, what will be the side? Sin of, instead of theta I am putting pi by 3, and this is sin 3 pi plus pi is 4 pi by 3. So, this can be written as sin 4 pi by 3. So, I got here sin x equal to sin 4 pi by 3. Then what is the general solution? X equal to, according to the general solution, sin x equal to sin y implies x equal to n pi plus minus 1 raised to n into y. Y is 4 pi by 3, where n is an element of z. Now, next one. Next question. Solve cos x equal to 1 by 2. So, cos x equal to 1 by 2 means, for which value of cos we are getting it as 1 by 2? That's cos 60. Cos pi by 3 is equal to 1 by 2. Now, both are positive. Cos x equal to cos y implies x equal to 2n pi plus or minus y. Y is here pi by 3, where n is an element of z. Now, next one. solve tan 2x equal to minus cot of x plus pi by 3. Solve means we have to find out what is the value of x. So the question is tan 2x equal to minus cot of x plus pi by 3. So tan 2x is equal to, given question is minus cot of x plus pi by 3. Then how can we make it as positive? What is minus cot theta? Minus cot theta is tan pi by 2 plus theta is minus cot theta. And here given a value is minus cot of x plus pi by 3. So what will be the left side? It will be, instead of theta it is x plus pi by 3. So tan pi by 2 plus x plus pi by 3. It is, instead of theta I put x plus pi by 3. So here also, instead of minus cot of x plus pi by 3, I can write it as tan of pi by 2 plus x plus pi by 3. And that is equal to tan of, here this side is tan 2x. So tan of pi by 2 plus pi by 3, that is 3 pi plus 2 pi, 5 pi by 6 plus x. Now we have got in the form tan x equal to tan y. If tan x equal to tan y, then x equal to n pi plus y. So same thing we can apply here. So 2x equal to, instead of x here it is 2x equal to n pi plus y is 5 pi by 6 plus x. Or this x also we can take it to same set. So 2x minus x is equal to n pi plus 5 pi by 6. 2x minus x is x. X is equal to n pi plus 5 pi by 6, where n is an element of set. So this is the way of finding out the solution. Now next one. Next question. Solve sin 2x minus sin 4x plus sin 6x equal to 0. So this equation we can write it as sin 6x plus sin 2x minus sin 4x equal to 0. And these two, if I am applying the result, sin x plus sin y is equal to 2 sin x plus y by 2 into cos x minus y by 2. So this can be written as 2 sin 6x plus 2x by 2 into cos 6x minus 2x by 2, and remaining minus sin 4x equal to 0. And that is 2 sin 8x by 2 is 4x and cos 4x by 2 is 2x minus sin 4x equal to 0. In both these we can see sin 4x is common, that can be taken out. Remaining 2 cos 2x minus 1 is equal to 0, or sin 4x equal to 0, or 2 cos 2x minus 1 is equal to 0. Now if sin 4x equal to 0, what happens to the value of x? For which all values of x we are getting it as 0. Sin of some value equal to 0 means this angle, that value will be multiples of pi. Sin of multiples of pi only will get the value as 0. So I can write 4x equal to n pi, or x equal to n pi by 4. Then, or here 2 cos 2x is equal to 1. Here what can I write? Cos 2x is equal to 1 by 2. Or cos 2x equal to 1 by 2. For which value of cos we are getting it as 1 by 2? Cos 60. Cos pi by 3. So cos 2x equal to cos y. Cos x equal to cos y implies x is equal to 2n pi plus or minus y. So here 2x equal to 2n pi plus or minus pi by 3, and multiplying throughout by dividing throughout by 2, we are getting x is equal to n pi plus or minus pi by 6, where n is an element of z. So what are the answers? Two answers will be there. You can write the solution as x is equal to n pi by 4 or n pi plus or minus, or x is equal to n pi plus or minus pi by 6, where n is an element of z. Now next question. Solve 2 cos square x plus 3 sin x equal to 0. 2 cos square x plus 3 sin x. Since one is in terms of cos, other one is in terms of sin, we can't make it as an equation. To solve it will be difficult. So what we have to do is we can change this cos square x in terms of 1 minus sin square x. So 2 into 1 minus sin square x plus 3 into sin x equal to 0. Now opening the bracket, 2 minus 2 sin square x plus 3 sin x equal to 0. Now rearranging this, 2 sin square x minus 3 sin x minus 2 is equal to 0. So we can write it as factors. Here 2 into minus 2 is minus 4. Minus 4, factors of minus 4 are, here we can split it. This minus 3 should be splitted. So we can take what are the factors of minus 4. Minus 4 can be taken as minus 4 and 1. So adding this, we are getting the middle term. So we can split this as 2 sin square x minus 4 sin x plus sin x minus 2 equal to 0. Common terms taking out. From the first 2 and taking 2 sin x outside, remaining sin x minus 2. And last term this side is sin x minus 2 itself equal to 0. Again from these two terms, sin x minus 2 is common, remaining 2 sin x plus 1 equal to 0, or we can write this as sin x minus 2 equal to 0 or 2 sin x plus 1 equal to 0. From here what we are getting, sin x equal to 2. Is it possible? It is not possible, because the value of sin x will go up to 1 only. So sin x equal to 2 is not possible. So only possibility is 2 sin x plus 1 is equal to 0. That means 2 sin x equal to minus 1 or sin x equal to minus 1 by 2, or you can write sin x equal to minus sin 30 is 1 by 2. Sin 30 means pi by 6. Now we have to make this as positive angle. So we know sin of pi plus theta is minus sin theta, and we have got here as minus sin pi by 6. So this side will be sin of pi plus pi by 6, and that is sin 7 pi by 6. So instead of this I can write sin x equal to sin 7 pi by 6. So sin x equal to sin y implies x equal to n pi plus minus 1 raised to n into y, or here x is equal to n pi plus minus 1 raised to n into 7 pi by 6, where n is an element of z. So that is the general solution of the given question. So the next we have to move on to exercise 3.4 that I will be discussing in the next video. Thank you for watching my video. Those who haven't subscribed, please like, share and subscribe, and also click on the bell icon for more updates and notifications. Bye.